Section 8.2, Rational Exponents. Please make sure you spend lots of time on this section because for some reason this does give students a little bit of challenge, so make sure you spend some time understanding what does it mean to be a rational exponent. Well, first of all, what word should come to mind when you see the word rational? Fractions. Okay, so we're going to deal with fractional exponents. So if I have base a raised to the 1/n, I want you to realize that fractional exponents are just radicals, and radicals can be rewritten as fractional exponents. So we're going to go back and forth between radicals rewritten as fractional exponents and fractional exponents rewritten as radicals. So what happens is a is going to be the base, 1's the power, and n is the index, so this would be our radicand. So if this is base raised to a power and we want to write it into a radical, the nth root is our index, a is our radicand, and it's raised to the first power. So there's where the 1 comes from, there's your index, and a is the radicand. We don't really need the 1, but we're going to continue writing it to make sure you see it. So rewrite using radicals and then simplify if possible. Don't just type these into your calculator. That is not going to help you. Understanding how you rewrite these is crucial. So 36 to the 1/2, I'm going to rewrite using radicals. So the index is a 2, I don't need to show the 2, and the power is a 1, I don't need to show the 1. And the square root of 36 is just 6. So 36 to the 1/2 is 6. On number 2, we have 16 raised to the 1/4. The 1 is the power, the 4 is the index. So it's the 4th root of 16. Again, don't just type this into your calculator. The 4th root of 16, what can you multiply 4 times? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2. Therefore, 16 to the 1/4 is 2. Now be careful. This is in parentheses, so the negative has to be under the radical. 1's the power, 3 is the index. So this is the cubed root of negative 125. What can you multiply 3 times and get a negative? Well, first of all, we're allowed to because the negative is under an odd index. And the answer would be negative 5 because negative 5 times negative 5 times negative 5 is negative 125. So the answer to number 3 is just negative 5. And then we have 16 over 49 raised to the negative 1/2. Remember what negative exponents do. We're going to distribute to each one, so we get 16 to the negative 1/2 over 49 to the negative 1/2. Well, since this is a negative exponent, it's going to go up. This one has a negative exponent, so it's going to go down. So we end up with 49 to the 1/2 over 16 to the 1/2. Power 1, index of 2. So this is the square root of 49. Power 1, index 2. So square root of 16. And square root of 49 is 7. So this just turns out to be 7/4. Again, make sure you understand the concept. Don't just type this into a calculator. That's not helping. 9 to the negative 1/2. This is a negative exponent. So we're going to take the whole thing down to the denominator. So there needs to be a 1 on top. Power 1, index of 2, tells me 1 over the square root of 9. And the square root of 9 is 3, so we end up with 1 over 3. Now so far those have not been so bad because the power has all been a 1. But what happens when the power is not a 1? So rewrite a rational exponent with a numerator other than 1. So again, the a is going to represent the radicand. The m is your power, so it's not going to be 1 anymore, and n is still the index. So there's 2 ways to write this. You can have the nth root of a raised to the m power on the inside, or the nth root of a with the radical all raised to the m on the outside. To be honest, this way is going to be easier. So I'd make sure you understand you can put the power on the inside or you can put the power on the outside. I recommend the power on the outside. So let's try some examples. Rewrite using radicals and then simplify if possible. So remember, the 4 is the power, the 3 is the index. So this is a cubed root of 8, and you can put the 4 on the inside, or the cubed root of 8, and you can put the 4 on the outside. I recommend this way, not this way, because here you're going to have to do 8 times 8 times 8 times 8, and then take the cubed root. Not sure what that is. But on this way, you know what the cubed root of 8 is. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. And now you have to do 2 to the 4th power. And 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. So 8 to the 4/3 is 16. Now if all you're going to do is put this into your calculator and get this answer, you're not going to understand any of this, and that's going to be a problem coming up. So make sure you're actually doing the work, not just typing it into a calculator. 9 to the 3/2 says the square root of 9, all raised to the 3rd power. The 3 is the power, the 2 is the index. The square root of 9 is 3, and then I'm going to have 3 cubed, and 3 cubed is 27. So we end up with 27 as our answer. We have negative 27 to the 2/3. Now here's where you really have to be careful. That negative is not in parentheses, so it's not being raised to that power. So the negative stays on the outside, and you have the cubed root of 27 all squared, but still with that negative not being squared. For that negative to be being raised to the power, you would need to have parentheses. So we get negative through the cubed root of 27 is 3, and then I still need to square it. 3 squared is 9, and that negative stays on the outside, so my answer is negative 9. Again, if it was in parentheses, then that negative would have been under the radical. On number 4, we have 81 to the 3/4. Power 3, 4 is the index. So the 4th root of 81, all raised to the 3rd power. What number can you multiply 4 times and get 81? That's 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81. And then I need 3 cubed, which is 27. So negative 32 raised to the negative 2/5. What does that negative power do? It moves it down. So 1 over 32, negative 32 raised to the positive 2/5. So now we're going to rewrite that with power and index. Your index is a 5th root of negative 32, and that's going to be all raised to the 2nd power. Can you have a negative under an odd index? Yes, we decided we were allowed to do so. So what number can you multiply 5 times and get negative 32? Well, it would be negative 2. Negative 2 times negative 2 5 times will give me a negative 32, and we still need to square it. Because that negative is inside that radical, you're still squaring that negative, so you end up with a positive 1/4. Negative 27 to the 5/3. Power is 5, index is a 3. So this would be the cubed root of negative 27, all raised to the 5th power. With a negative underneath an odd index, that is allowed, and negative 3 times negative 3 times negative 3 is negative 27, and we're going to raise it to the 5th power. So take negative 3 and raise it to the 5th power, and you're going to get negative 243. So we have 4 to the negative 3/2. How do we do 4 to the negative 3/2? Well, we start off by taking it down to the denominator and becoming a positive 3/2, so 1 over. This is your power, this is your index, so we end up with 1 over the square root of 4 cubed. Square root of 4 is 2, so 1 over 2 cubed, and 2 cubed is 8, so we end up with 1 over 8. We have 25 to the 1/2 plus 100 to the 1/2. Well, 25 to the 1/2 is just the square root of 25, power and index, plus the square root of 100, again power and index. The square root of 25 is 5, and the square root of 100 is 10, so 5 plus 10 is 15. So what I wanted you to make sure you understood from this section was going from a fractional exponent, turning it into a radical, and simplifying. In math, we always like to go both ways, so we're going to go back in the other direction in just a little bit. Right now, I just want you to rewrite in exponential form. I didn't say anything about simplifying, just rewrite. So what does 33 have a power of? Well, it has a power of 1. So if I rewrite in exponential form, I end up with 33 to the 1 over 8. Power divided by index, so 33 to the 1/8. On number 2, this is your power of 3. Your index is 5, so we get 7 to the 3/5. Now be careful here. We're going to want to bring this back up and make it a negative exponent. We're going to want to bring it back up and make a negative exponent. So power of -2, index of a 3. So we end up with x to the -2/3. So here's what we have to make sure we understand and learned those rules of exponents. When you're multiplying, you add powers. When you're dividing, you subtract powers. When you have a power to power, you multiply. So we need to make sure we still know all those rules of exponents. So use rules of exponents to simplify. I did not say anything about changing this into a radical. We are not changing it into radicals. We're using rules of exponents. So I would write this down because a lot of students start trying to change these things into radicals, and that's not what I've asked you to do. I've asked you to do what? Use rules of exponents to simplify. So make a note. This is when we multiply, we add powers and so forth. So when we multiply, we keep the base and we add the powers. Well, to be able to add, we have to have a common denominator. We do have a common denominator, so we're going to get x to the 8/4, and 8 divided by 4 is 2, so I end up with x squared. The rules of exponents say when we have a power to power, we multiply. We do not find common denominator, we just multiply straight across. So we end up with a to the 2 times 3 is 6, and 3 times 4 is 12. And we reduce 6 over 12 to 1 over 2. Again, it did not say change into radicals. It just said rules of exponents. This is a radical because we know that fractional exponents are radicals. So we could take a fractional exponent and turn it into a radical, but that's not what I asked. Rules of exponents. Make a note of that. So on number 3, we have power to power rule again. So we're just going to multiply the power times every power. We have to distribute our power in. So I'm going to write it out. I'm going to have x to the 3/4 times 4/5, y to the 1/8 times 4/5, and z to the 5/6 times 4/5. Now you can either multiply straight across and then reduce, or you can just reduce as you go. On the next one, 4 can go into 8 2 times, so I end up with 1/10. And z to the, again over here the 5's cancel and 4 6 reduces to 2/3. If you can't do it that way, multiply straight across and then reduce, and you're going to get the same answer as what I have. For number 4 for you to do, I will give you the answer and make sure you can get to it. The answer would be y to the 1/6. So we have power to power rule, so you're going to multiply and then you will subtract. Alright, so on number 5, we have n to the 2/3 times n to the -4/5. I do not like working with negative exponents, so I'm going to make it a positive exponent by taking that one to the denominator. Then when I'm in the denominator, I see when I am subtracting, when I'm dividing, I subtract exponents. So n to the 2/3 minus 4/5. You might think that's not a necessary step, but again, I want students to realize negative exponents make things go down. So now we need to find a common denominator, which is a 15. So we're going to make both of those denominators become a 15. This would be multiplied by 5, so 2 times 5 is 10. This would be have to multiply by 3, so 3 times 4 is 12. So we end up with n to the -2 over 15. We're not going to keep negative exponents, so we're going to move it down. So we end up with 1 over n to the positive 2 over 15. So make sure you get rid of your negative exponents. So I'm going to let you try number 6. and I'll give you the answer. You should end up with 15 p to the 5/9. So on number 7, we have x to the 5/8 over x to the 1/4. When we are dividing, we subtract exponents. So we have x to the 5/8 minus 1/4. We need to find x to the 5/8 minus 1/4. We need to find common denominator, which would be an 8. So this would be x to the 5/8 minus, this needs to become an 8. So 2 times 1 is 2. So we end up with x to the 3/8. On number 8, again, I'm going to circle. Power to power rule just means you need to multiply and then reduce if possible. And you should end up with m to the 3/5. All right, number 9, we multiply straight across, and when we multiply, we add powers. So -6 times -7 is a positive 42, and we're going to have y to the -5/6 plus 5/3. We could take that one down, but we're going to just use rules of exponents. When we're multiplying, we add our powers. We do need to find a common denominator. So 42y to the -5/6 plus, this needs to become a 6, so you have to multiply by 2. Whatever you do to the bottom, you do to the top. So you have 10/6. So we get positive 42. 10 minus 5 is 5/6. So you end up with 42 y to the 5/6. And number 10, we have power to power rule. Remember, 3 does have a power 1. So you need to distribute your power to every power, which is just multiplication. So we end up with 3 to the 4th. X to the 5 times 4 is 20 over 4, which just turns out to be 5 all over x squared. So we end up with 3 to the 4th. Again, 20 divided by 4 is just 5, so x to the 5th over x squared. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, and when I'm dividing, I subtract exponents, so we end up with 81 x to the 3rd. So now we're going to get back into rewriting with smaller root indexes and performing. We're going to stop there for now, and I'm going to make this part B because this is getting into a little bit of a different part of the radical in chapter or section 8.2. So I'll continue this in part B of this video.